So this is Earth, and this is Venus. They're about the same size. They're actually sister planets. Venus is a little bit closer to the sun, the Earth a little bit further away from the sun. The Earth is this beautiful blue planet covered in oceans. Venus is a hellhole. In spite of it being the goddess of love, or perhaps it's appropriate that it is the goddess of love. But that's another story. The surface of Venus is so hot that it would melt lead. It has intense acid rain falling. It's covered in clouds. The reason it looks so bright in the sky is that it's completely swathed in clouds. You have to use special instruments to penetrate through the clouds and see the surface beneath, like that. So why would that be? Venus is closer to the sun, but not that much. It's about the same size. It has a similar history to the Earth. There's one important difference between Venus and the Earth, and that's that Venus has in its atmosphere very large amounts of greenhouse gases. The Earth has smaller amounts of greenhouse gases in the atmosphere. And we're in the process of changing that. I'll bring you back to that in a moment. Okay, so this is a little bit of my journey. That's me, there. This is me in my previous incarnation. First of all, I was a scientist, and then I was a teacher in universities, and then a researcher, and then I started being a writer. And I went around the world finding interesting things, understanding or trying to understand how the Earth works, how it all fits together. So I'm in Namibia here, and I was there to write my first book, which is about an amazing climate event that happened 600 million years ago. And as I was researching for this book, I discovered how intimately everything on the Earth fits together. You have to understand not just the rocks, not just the oceans, not just the ice, not just the atmosphere, not just the biology, not just the chemistry, not just the physics. You have to understand everything, how it all fits together. And if you don't understand all of it, you don't really understand any of it. And I was quite thrilled by that because at school, the US is much more enlightened than the UK, where I grew up, the United Kingdom. Everyone was always telling me I had to specialize, I had to specialize, I had to specialize. But what I've learned, and what I learned in my previous incarnation as a writer, writing about different ways about how the Earth works, is that actually it's where things fit together and where things connect that the most important things happen. So in the process of this, I then went on to my favorite place in the world, Antarctica. And as you heard, I wrote a book about it, and it really is an extraordinary place. And it is a place where you learn more than anything how all the different parts fit together. It's also a place that looks out into space. This is actually the South Pole. And the South Pole is full of the most amazing telescopes, and they have this unique window. It's a very special place because you can see things into space from Antarctica that you can't see anywhere else in the world. So the scientists there have managed to figure out some of the things that we now know about our place in the universe. And I'll come back to that as well. But the reason I wanted to talk about Antarctica now, apart from the fact it's a little bit of an obsession of mine, is this. This is me again. And it's like, when you're standing there at the South Pole, it really feels like you're on the moon. There's nothing and nobody. There's no life, there's nothing. It's actually quite thrilling. I do like people, really I do. What I'm standing on here is even more astonishing, because what I'm standing on is actually a mountain of ice. It's a mountain of ice. That ice is miles, it's about 2.5 miles thick. And the ice has been accumulating on Antarctica for hundreds of thousands, for millions of years. So right in the center, it's a bit like being here in Santa Fe. You get altitude sickness, and you get kind of dizzy, and you don't really know what's happening. But this mountain of ice has something very special to tell us. Because when it was forming, the snow was falling, and more snow fell on top, and more snow fell on top over hundreds of thousands of years. And that squeezed it and turned it into ice. And it turns out that you can drill down into that. You can drill down into it, and when you're drilling down into it, it's almost like being in a time machine. You're looking further and further back, the deeper you go, to the older and older ice. And this is the oldest ice that's ever been recovered from Antarctica. It was 3,200 meters down. And the reason that that's so important is that Antarctica is like a library or a history book or something. it's trapped the history of our climate in that ice. And if you drill down into it, you can actually understand what we've been doing to our climate. So that's what an ice core driller looks like. That's what the ice core looks like. And the ice is full of bubbles. The ice is full of pieces of air that were trapped hundreds of thousands of years ago and have never escaped since. So these particular pieces of air were trapped before humans were even invented. They were trapped 800,000 years ago. I was lucky enough to be there in Antarctica while they were finishing the drilling, and they brought up that last piece. It was a joint French and Italian base, and so they had fantastic food. And they also did a big party. They had massive bottles of champagne, and they gave us all champagne, and they put little shavings from the oldest ice in the champagne, and you could hear the popping of the bubbles that have never been breathed by humans before. That's how we celebrated. I have to say, tasted a bit of drilling fluid, to be honest. But it was very nice of them, and it was nice to join the celebration. But there's a very serious point here, really. Because I did breathe that air, and the air that was 800,000 years old, and then there's air that's a little bit younger and a little bit younger and a little bit younger, all the way up to the present day. You can trace the history of our air. Pieces of air, real pieces of air. This isn't some kind of construct or model. This is pieces of the atmosphere that show how our atmosphere has been changing. And what it shows is that sometimes it gets a bit warmer, there's a bit more greenhouse gases in the air. Sometimes it gets a bit colder and there's fewer greenhouse gases in the air. Sometimes it gets a bit warmer, all perfectly naturally. And then in the last 150 years or so, the levels of greenhouse gases, carbon dioxide, methane, and nitrous oxide have skyrocketed. There's very considerably more of them in the atmosphere now than there have been for at least 800,000 years, and we know that from Antarctica. Is it accurate to say that bad stuff's happening? Yes.
Okay. Glad we got that out of the way. So I was going to begin with a question about science. Mm-hmm. Sorry, audience.
Science is great, don't say that.
No, I am not just an international man of mystery, I'm also a science educator. I forgot to announce what I do for a living. So in her best-selling book, Silent Spring, published in 1962, which woke up the people of the world to the dangers of the massively increasing production of synthetic chemicals and their unchecked dispersal into the environment, leading to the contamination of the biosphere and poisoning all life, not dissimilar to the unchecked production of greenhouse gases today. Rachel Carson gave a couple of reasons why the problem had arisen. Quote, "This is an era of specialists," noting your conversation where you began your talk, "each of whom sees his own problem and is unaware of or intolerant of the larger frame into which it fits. It is also an era dominated by industry, in which the right to make a dollar at whatever cost is seldom challenged." What Carson points to is the power of science and technology having been harnessed in our society in ways that have contributed to the planetary ecological crisis with which we are confronted today. So as a scientist and journalist, how do you see this seeming contradiction between the lofty ideals that scientists set themselves to solve social problems and the way in which those goals can be warped by larger social forces?
I think I might disagree with most of that, actually. Let's give it a go. I don't disagree with Rachel Carson. She's obviously one of my heroes. But I think, first of all, I'm not sure that scientists really feel like they have a kind of moral purpose to their science, at least haven't historically. Science is there to try and understand the world, and then the world can decide what it wants to do with it. And this is one of the reasons that we managed to get into this mess, I think. I've spoken to lots of my friends who are scientists now who are trying to change it, because we don't actually teach our scientists. We teach our scientists the scientific method, how to do science, how to understand, and we try and make them reduce and reduce. But we don't teach them how to deal with the implications of their science for the world and how to take that in. I mean, when Sherry Rowland and the guys discovered the problems with the ozone layer, discovered the implications of the chemicals that we were using for refrigeration for the ozone layer, they put out a paper, and they expected there to be great fanfare, and nothing happened. And then they had to give a press release at the conference, and they didn't really know how to do that properly, and it wasn't part of the story. And it still really isn't. So I think that there has been a mismatch between the sort of science that's happening and the social implications for scientists. But I'd also say that there's the part about it which is science has created the problem in terms of, or certainly technology has created the problem. And the thing that I wanted to add there is that our technological development has also brought vast benefits to very large numbers of people on the planet, and increasingly more so. Our health, our level of well-being, and many of the problems that we face are radically different and radically improved from the way that they were even a century or 50 years ago, largely as a result of technology. So it's not it's the saint or sinner. It's the right or wrong, black or white part of the story that I think has also got us partly into this mess. Because I do think that technology has been a very serious part of creating this problem. I do think technology can be a very serious part of solving it. But I don't think it helps to say there are the forces of technology and industry ranged against the forces of pure science and the people. Because I don't think that's true anymore.
Well, that's what she was saying.
I know, I understand, and I don't think it's true anymore. And also, increasingly in science, there's this development. I mean, here in Santa Fe, you have the very fine Santa Fe Institute, which is particularly brilliant at making connections. So, increasingly, it's not just geography or geology anymore. It's biogeochemistry with physics thrown in as well. It's figuring out how the different parts fit together. And I think that that's a very marvelous development for how we're likely to be able to solve this problem.